Hello, hello. Cool. Okay, everybody, welcome to Advent of Code 2021, JavaScript with Joe, day one. What we're going to be doing in this series basically is going through the 25 Advent of Code challenges, and I've set myself to do these once a week. So last year I tried to do this every single day, do a live stream every day of December, and it was way too stressful. And I think 9 days in, I'd had enough. So my plan this year is I'm just going to do it every Wednesday, hopefully at 4 p.m. GMT. So if you want to watch them live and ask questions and stuff, you can do. Hello, Matt Uwe, I see you in the chat. Welcome to JavaScript with Joe. Last year we did Python. This year we're going to be doing JavaScript. I'll try and explain stuff as if you've never programmed before or as if you've never programmed JavaScript before. But there's 25 of these, so that might get a bit repetitive. But we'll see where it's going and what the audience is like. But this is very casual, so it'll be available on YouTube afterwards. But if you're here live, feel free to ask questions and I'll try and take time to answer them. So first of all, this is Advent of Code. You can go to adventofcode.com and I will... Oh no, I can't send it in the chat. 1 second. I'll just share this link in the chat now, so it should always be there for future viewers as well. So you go on adventofcode.com/2021. This is the most recent year, but if you go to /2020, you can get 100 or so of these challenges from previous years, basically. And what it is a series of sort of connected programming challenges. They tend to be quite hard, and they tend to have two parts to them. So the second part will sort of usually try and punish you for cutting a lot of corners in the first part, so good programming will usually help out here. And I'm going to be using something called replit.com as well, and this is just basically a programming sort of editor or a text editor that you can use in the cloud, so you don't need to install JavaScript or Python or anything on your machine. So if you do ever just want to have a quick play around, you can type some code here like 2 plus 2 and it'll return 4. So that's just a good way of getting straight into programming instead of getting distracted with how you get started, I suppose. So you can get straight into that coding. Thanks for your thank you, Matthew. Okay, so let's get started. So day one. So again, with a lot of these challenges as well, people will jump straight into programming, but I think it's much more important to show that sometimes people aren't very good at programming, sometimes problems are too difficult, sometimes we get a lot of error messages, and I think you're kind of punished for that kind of thinking in more traditional teaching spaces. But here, by the end of this hour, we might not actually have finished this program, we might not have made any progress with this problem as well. So that's what you can sort of look forward to over the next couple of weeks. So to start with, hopefully you can read all of that. I see it's a bit cut off actually. Let's do a little bit tighter. Oh, too tight. Okay, there you go. You should at least be able to read it as I'm reading it now. Okay, so day one, sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is, and it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 5 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. That's not going to happen, but we'll see. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star and good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, which is our puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, 210, 200, 207, 240, 269, 260, and 263. This report indicates that scanning outwards from the submarine, the sonar sweep found depths of 199, 200, 208, 210, and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. In the example above, the changes are as follows. For 199, there's no previous measurement. 200 increased, 208 increased, 210 increased, 200 decreased. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? Okay, so we're just counting whether they all increase compared to the first one. And this is our puzzle input. So unsurprisingly here we have something that looks like it's sort of thousands long instead of, 7. But it's useful to see what we might be dealing with later, but for now we know that this is going to be our puzzle input. We may as well test if this works and hope that our logic is sound and that it can sort of percolate out to the larger problem. So that's our input. I'm just going to add these slashes in front of each line that set them as comments, so this won't execute anything, whereas if we uncommented them it would probably cause some sort of error because, it just returns the numbers. So I guess that's valid. JavaScript is just to say a number and it'll return our number, but we don't actually want that to happen, so I'll comment all that out. And really what we're doing is counting the number of times it increases, so I'll probably just keep a note of that for now, and we'll see where we get. Okay, so those are comments. Those aren't going to run when we do anything. This on the right hand side is what we call a REPL. You can see up there REPL. That stands for read, evaluate, print, loop. So if I typed, for example, 2 plus 2, it will read 2 plus 2. It will evaluate what we're doing there. We've got operators and operands. It's going to figure out that we want to run 2 plus 2 as a mathematical statement. It will then print out the answer to that evaluation, which is 4. And then it will loop, so it will just do that over and over again. And this is basically how we'll build up our code. We'll just have a series of individual lines, and they will run in sequence. So next notion we're going to have is something called a variable. So in JavaScript we could say something like variable my name, let's not do that, my age is equal to 27. And now I can call that variable my age, and it will give us back that number 27. So this is the first sort of powerful notion in programming, that we can store useful information, give it a useful name, and access it later. So that's what we're doing with my age. We can also do some maths with that, so we could do my age plus my age and get 54. So that's a variable, and we can just use it in the place of any sort of data that we would have used before, like those numbers 2 plus 2. We can also store a variety of different what are called data types. So I could do my name equals Joe. And it's a bit weird seeing that in quotes, but this is how we denote strings in JavaScript. We won't really be using that this time, so maybe we can focus on numbers, but it's just useful to be aware of this kind of stuff. And we can call the type of, I don't know if that's a function, but we can call type of and it'll tell us what this is. So my name is a string, type of my age will be some sort of number, but it might be a word we've not heard before. So it is a number here. It could be referred to as an integer or a float, or there's a sort of a variety of different types of numbers, but luckily in JavaScript this one's just called a number, so I don't need to explain that. I think we'll stick with that. No, we'll need a list or an array. So that's denoted with square brackets. So we could have a list of ages and some of my friends' ages, so maybe they're 26, 27, maybe there's some 30-year-olds in there, maybe there's some 36-year-olds in there. And this is what's called a list, so we could call this my ages perhaps. And we're using equals to assign this to that variable, so we're assigning the value of this list to the variable my ages. And again, we can access my ages whenever we want to. And with this, we sort of get a lot of cool helper functions that let us sort of iterate over this list, map over it, filter this list down. And to me, my goal with a lot of these problems is to try and think of them in terms of a list. And then I know that gives me access to a lot of sort of cool logic that I'm definitely going to need. Okay, so to start with, I think all I want is a sort of, I suppose, a sonar sweep. So we can say var sonar sweep, and maybe let's store this list. So later on we're going to need something that can read a file into a list structure, but for now I'm not going to worry about that. So I'm going to do 199, 200, 208, 210, 200, 207, 240, 269, 260, 263. And we know our output for this should be 7. And in JavaScript, you can sort of end a line with a semicolon, but if you skip it, nothing bad will happen most of the time. So then we can actually log out Sonar Sweep on the side and see all those numbers in order. There is also, in newer JavaScript, so we used to define all variables with var, but we also have keywords let, which will be for variables that can change, and const for variables that will never change. So in this case, we could probably use const, because we're not going to change this original sweep. And even if we do for lists, we can change those numbers individually, so that's not a problem. So we've got our input now. And I think to start with, all I want to do is get to this stage where I'm just printing out each of those numbers one at a time. So I could use what's called a for each loop, which can be called on a list. Then it needs a, how do I do this? It needs a name for each Sonar sweep. So what would we call that? I don't know, let's call it a sweep. That doesn't really feel right. I don't know. A ping, I'll take better names. Link for the code is to this REPL. Let me share that, sorry. And we've got a question as well. This bit is just running in the REPL, but assuming you'd write the main code in a JS file, like if you stop the REPL, all variables would be reset. Yeah, that's exactly right. When we run these files, normally we aren't running them in this REPL. The REPL is just sort of a useful and interactive way to sort of try out those odd little bits of code, basically. What we can do here is, this is an arrow function, sort of more recent JavaScripty stuff, but I'll rewrite this in a second. So that should just log out each one line by line. There we go. So we've got what we've got going on here. Now this isn't particularly intuitive code, and this is why last year I did it in Python. I find Python runs a lot more like plain English, whereas JavaScript does some weirder things like this. But that being said, we could rewrite this as something else. So maybe I'll write the sort of older version of this as well. So we could have for a more classic for loop for var, let's say ping equals 0, semicolon. So that's the sort of initial condition for this loop. Then how many times we want this loop to run. So we could say ping is less than the length of Sonar sweep, which is a property, and we access that with dot notation in JavaScript. Then another semicolon, and for our third statement we need to sort of iterate or increment, and we can do this. Again, in Python we'd probably write something like ping equals ping plus 1, but JavaScript actually has a shorthand for this, and we can just call ping plus equals 1, or we can even just say ping plus plus. Then curly braces for the content of this loop. So in here I'm going to do my console.log ping, and that will actually do the same thing as this line does below, though this line below does it a bit more succinctly. Oops, no it doesn't, because we have to access our Sonar sweep with our index, which I've called ping, so maybe I'll call that index instead. So that's a more traditional for loop that will iterate over the items in a list or an array. I've not talked about this notation before, but using this square bracket and a number we can access the elements in this list, and that starts at 0 and it will end at the one below the length. So this is sort of a disconnect between the reality of how we use lists and the sort of programming way we use lists, where we start counting at 0. So if I said Sonar sweep, I should be able to do it in here actually. Sonar sweep 0 will give me the first item, 199. Sonar sweep 1 will give me the second item, and how many are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I access the 10th item, I would use a 9. And if I access the 10th one, I'm hoping it'll error. It doesn't error, it just goes undefined. I mean, that's JavaScript for us, though. It's a bit less strict than Python would have been. Okay, so So that is equivalent to this line here. The difference is this is what we would call ES6 notation. So this came into effect in around 2015, and it's supposed to get us away from sort of these older patterns that we don't really need anymore. You know, we don't really want to write these new variables and increment over these indexes. What we just want is to say, I just want to do this for each thing in that list, and I just want to print it out. And this lets us do that, and it lets us assign sort of a friendly name to SonarSuite index instead of to ping. Did I send the code again? Sorry. I did. I sent the REPL again. Let me pop this chat out because I think it's a bit... My YouTube chat is a bit too small for me to see properly. Okay. Right, so now we're logging everything out. I'll make a comment just for this stuff. So comment traditional for loop, whereas this is a sort of, I believe it's ES6 for each. That might not be right anyway. Okay, so now we're printing out everything. We need a way of comparing this one to the one before. And to be honest, it could be better to do that with this for loop, because then we can keep some sort of notion of what happened before. But I'll try and do it in here. So if there's only one line, we don't need those curly braces in this notation, and that's just something, again, quite confusing about how JavaScript does stuff. But if we do this, then we should be able to write further lines. So instead of just logging it, I actually want to store this in a variable. So let's define a variable out here called, let this be, I don't know, the last, oops. Let this be the last ping, maybe makes sense, last ping, and let's set that to be the first sonar sweep as well. So in this case it'll be 199. And then we can check, is this current sonar sweep greater than or less than the previous sonar sweep? In this case it'll be equals to. I believe we don't have to deal with that case. So we could assume that's equal to, though that might be a bad thing to do, but we'll see if that hurts us. So this will be our first if statement. So we can do if ping is greater than last ping, then we're going to print out increased. Why don't we actually do this as the format they want, so the number and then increased or decreased. So we can do that with something called string concatenation. So we could do ping, can we do ping? Yeah, ping plus space increased, and else it's, well, it might be the same, so we actually need an else if ping is less than last ping, then we have decrease. So we can do console.log ping plus decreased. And then there's an else, but we can just ignore that. Nothing should happen in that else anyway. And then we need another one of those. Okay. I guess I can put that on one line as well. So now it'll just log ping if they're equal, so it should just do, in fact this is that no previous measurement assumption, although really it's not that the previous measurement, it's just that we don't have anything we need to do when they're the same. Oh no, I'm getting comments from someone who needs to get the heck out of here. Oh no. Matt Uwe, I'm just going to make you a cheeky moderator, but I'm getting apologies, or I just have to delete some strange messages on my live stream. I think I've sorted them. I don't want that either. Okay, let's try running this now anyway. Okay, so we're getting... So we get that correct match on the initial one. So 199 is equal to 199. So it's falling into an else, NA no previous. Then we're getting ping is greater than last ping, increase. But then we have a problem. It's always increasing. So you can have a think about why that's happened. I already know that's why that's happened. but I'll give you a second and I'll spell decreased correctly. So what's going on here is we're not actually updating the last ping in each of our for loops. So after we've done all that logic, we need to update last ping for our previous for our next iteration. And we can just do that with last ping equals ping. We already defined that variable, so last ping is accessible in here. And there we go. So we've got 3 increases, 1 decrease, 3 increase, 1 decrease, 1 increase. And is that what we're expecting? Increase, 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 decrease. Yeah. Okay, so we've got it now. Our actual answer here is that there's 7. So we need to count the number of increases. Oops. I'm going to close all those things as well. Apologies. Okay, so all we need to do now is count these increases. So we don't actually need all this logic here. And let's do a variable total equals 0. And all I'm going to do is inside this increase case, I'm just going to increment total. So again, we could do this by saying total is equal to total plus 1. And that would reassign total to be 0 plus 1. But we can also just do this with total plus plus. And let's log out the total at all steps as well and see what we get. Log total. So we should just get a number on each line with the number of increases. So we get no increase, 0, increase, 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 decrease, it doesn't increase, and we get 7 at the end. So that looks good. We can also change some of this stuff. Maybe this could use something called string interpolation. So again, a newer feature. If we use backticks, we can use variables like this, but we can actually keep them in line with the string, so we don't have to worry about concatenation or adding in extra white space. And that will log exactly the same thing. Same in here, we can do ping, decreased. Those are the same lines, so I can get rid of those. Cool. And then I'm only going to log the total once, so it doesn't need to be inside that for loop anymore. That should give us our answer. Not increment, overwrite with this ping. If the ping has increased, else if, maybe I'll put that inside the if statement. No, let's put it there. If the ping has increased, if the ping is the same. Anything else I want to change? We don't need this traditional for loop, but I'll leave it there. I'll move this into here. Don't need that for loop comment. And I don't need this big intro bit. So that's sort of our general. I kind of want to delete that, but I won't. Yeah. Apologies, love face XYZ, but you're not getting any more JavaScript lessons from me. Okay, so now we should just get that 7 printed out at the end. Cool. So we've got our correct answer for this test case. The next issue we have is that, again, our puzzle input is huge in comparison to what we've been playing with. I can't realistically just write that in. I am trying to time limit these to half an hour for each star as well. So it's not realistic that I'm going to be able to write those all out here. I'll paste the puzzle input in the chat, actually, just so you understand how big we're talking. Oh, I can't, because it's too big. It's about 10,000 characters, so we're not going to realistically type that in. So what we probably need to do is find something that lets us read this in from another file. So again, another benefit of REPL is that on this left-hand side, we can add files, we can install packages, run a debugger, all sorts of stuff. So in here, I can add a file, and I'm just going to call it input.txt. Paste that in there, and then all we need to do is find something that can read this in line by line. So read in file line by line into array JavaScript. And this will be something that millions of people around the world have already written, so I can probably just copy and paste something easy here. Let's try. Let's give this a go, since it looks a bit easy and one-liney. So text is equal to read file sync // means here, so there's only one place these files can be. Input.txt, and hopefully that should just give me a text variable. No. fs is not defined. Okay, so I need to, this is because we're using a separate package outside of what REPL provides, so I should just be able to import that with this require notation. And I think I can. So if I type text now, okay, I get all of my numbers, but they're not in a list, they're in, what are they in? I don't know what this is. It's not a list, I don't think. It seems to be like one really big string, so that's not quite right. This doesn't really do what I want. Oh, but this does with, okay, so currently it's a string. So what I can do is I can split on this escape character here, which refers to a new line. I should just be able to do that like this. So dot split will this is a function of strings that I can split on a particular character, and I'm saying split on the new lines. Okay, so that's worked, but now they're all strings instead of numbers. So in other languages this might cause a problem, but in JavaScript it might not. It might just assume that we want, yeah, it does actually work even though there's strings there. So I guess when we run this comparison, it's converting them to numbers anyway. So I don't actually need to do anything else, though. That's because it's still reading in this Sonar sweep. Okay, so I am overwriting it. So let's test it with this and see if it actually breaks. And I shouldn't need this Sonar sweep line anymore. Instead, this should be my Sonar sweep line. I think that worked. So now I should be able to paste the actual full input into here. And we should get a very long run. There we go. So we can see there it's got all of our increases and decreases. We can confirm a few of them. That one's clearly increased, that one's clearly decreased. And we have our final number. So this is our first attempt, 1461. If you are running this yourself, your submission will be different. You'll have a different puzzle input than I will, but this is my answer. So 1461, and that's brought us just about to halfway time-wise as well. So I'm hoping that, well, my assumption for the next part is that we probably shouldn't be ignoring either the equals, or I think it's going to ask us for a total of how much the depth has increased over this time or something like that. Oh no, my answer is too low. That's not good. Make sure we're using the full input data, which I think we were. Let's check it actually. It's a fairly good hunch. No, 6632 is the final answer. So somewhere we're going wrong here. It's possible that there are repeats in this data set that we're not aware of. Though I don't know if that would be assumed as a repeat. You know, something that falls into this else statement would show up with this NA message. That could be the source of some of our miscounts, but it doesn't look like it happens. At least it doesn't happen where I can see it. I could ignore these console logs, and then we should get a run that only has those duplicates, but that's only the first case. So something's gone wrong here. We are also comparing strings to strings when we should be comparing numbers, I think. So if I say type of last ping, I think it's a string now. That could be causing some problems. For example, it might be that the string 1000 is considered lower than 999, for example. Though I don't know if I'd be able to see that, but that could, we could be off by 1 or 2. How to convert strings to integers is probably the next question we need to ask. I would imagine JavaScript has something like a toInt function. Here we go, parseInt. So if I do 123 dot parseInt round brackets, or maybe not. How do I use this? Integer.parseInt. Integer.parseInt, and that takes a string 123. No, integer is not defined. Hello, Georgina. I'm live streaming.
Yeah, I mean, you're looking at Java instead of JavaScript.
I'm looking at Java instead of JavaScript. Thank you, Georgina. How did she know that? Oh, I never searched JavaScript. Nice. Georgina, if you want to help, you can comment on the live stream. What is the difference between Java and JavaScript? Get asked that quite a lot. They're just different languages. Cool, so parseInt on its own would have worked. Thank you, Georgina. And what we need to do is sort of map over this. So again, we could write a for loop and replace all of those values. We could just do a little cheeky map here, though I'll do it on a separate line. So a function we haven't looked at is the map function, which is quite similar to for each, but basically we can return items back and build a new array of numbers. So we could have, in here we'll have strings, and we'll return that string converted to an integer. And we can actually just add this map onto here to our split. So now when we read in, we're reading in that file, we're splitting on the new lines, and then we're converting each of those strings to an integer. And now we get 1462, so that's looking good. So I'm imagining somewhere around maybe the 1000 number mark, maybe 1000 is considered less than 9999 because of its string length or something like that. I could probably test that if I delete some of these lines. Let's just go back to around here. I'm thinking that's the problem. Oh. Though I'm not sure if we'll be able to verify it. So let's see what it does around the 900 mark. Looks okay there. Yeah, I don't know. Well, we don't really need to figure that out, but there's definitely something has gone wrong in assuming that we could use strings, and this will be why some people say they don't like JavaScript anyway. But luckily, I had a hunch. Okay, so 1462. There we go. That's the right answer. I need to go ahead and make a little celebration GIF maybe for next week, but I didn't have one this week. So, part 2 will be some sort of tweak on that problem. Oh dear. Considering every single measurement isn't as useful as you'd expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example. I don't know how this is supposed to help me visualize that. I suppose you would be including the last 3 terms instead of the last ping. So we could just add 2 more variables: last ping, last ping, last ping. I was running it as strings, Matt. Only when I started reading in from a file, it assumed they were strings instead of numbers. Okay, so start by comparing the first and second 3 measurement windows. The measurements in the first window are marked A, so the first window would be 199, 200, and 208, and calculating their sum. The second window is marked B, 200, 208, 210, its sum is 618. The sum of measurements in the second window is larger than the sum of the first. Now this comparison has increased. Goal is now to count the number of times those windows increase from the previous. So exactly the same, but instead of comparing one with the other, we're comparing these three with these three. Okay, and we should be getting 5. So we can go back to our original test input now. And I'll close that for now. And we need to tweak this so that we're reading 3 numbers at a time instead of 1 number at a time. So we need to do this in a way that my concern is that we can't just grab these 3, because the first time we run we'd be looking at that first case, and the last time we'd run we'd be right on the edge of the array. So this might be where, instead of the for each, it could be more useful to think in terms of this original for loop, so I'm glad we kept it. And then we can just paste all of this code in that for loop and check it still works. We're going to have to tweak those. Well, we're going to need a definition of what a ping is. So ping is equal to Sona sweep index, but otherwise that's the same code now, so we should still get 1462 if we comment this out. Oh, we should get 7, sorry. Maybe I'll test that with the full code just so I'm not perpetuating something. Cool. Okay. Right, so instead of counting from the first one to the last one, we probably want to count from the... We can sort of use these numbers here. So counting from the first one, we would actually want ping 1, ping 2, and ping 3 to be Sona sweep index plus 1, and Sona sweep index plus 2. And then in there we can, oh geez, okay, so this total equals ping 1 plus ping 2 plus ping 3, and instead of comparing to the last ping, we actually want to compare to the last total. So down here we need to increment that last total to equal this total, and instead of initializing last ping to Sona sweep 0, we want to initialize that to Sona sweep 0 plus Sona sweep 1 plus Sona sweep 2. And ping is not defined, so somewhere in here. Oh, we're still using it all over the place. So this needs to be now this total. Oh, we can actually, so we can find and replace these. So if you press Control D or Command D, oh no, that won't work. Okay. So replacing all those pings there and replacing all the last pings with last total. Last total is not defined because the variable name is still total here. Is that right? No, the variable is still last ping in our initial definition, so updating that name should help there. We get 5. That's pretty good. Is that what we're expecting? 607, 618, 618. And we want to log out no change instead of no previous measurement. Though we will, again, we have that issue where the first one counts as no change, and it shouldn't. So that one shouldn't be no change, and you can see it's actually slightly over counting at the end. So that last window should be 792, but it seems to be sort of erroring there, and we're kind of lucking out. I mean, I was gonna, instead of counting all the way to the end, if I put -2 here, it'll stop it executing too earlier. That was my plan anyway. But it looks like the answer is correct there. Hello, John Stone. I'm just teaching JavaScript. Got a message from John Stone. What are you working on? Today we're doing the Advent of Code Day 1 challenge. Okay, so I think that might be everything we need to do now. I mean, we said that before. Let's see what happens. So we've got our answer 1497. Sounds like that could be a slightly more accurate version of that 1462 we got earlier. I guess my next question is there anything we actually want to change now? So I've got my reading in file, read in from inputs.txt, input.txt even. We've got our last total, so calculate the first total and sum increases. Then we've got a for loop, so from the first position, then this is our logic to add up our pings. Add up pings. Got increase, decrease, increment our total, log out the total, and let's get rid of that. Console log total. I guess my only other tweak would be changing this to use string interpolation instead. So that should be, this just lets us basically write JavaScript within the string, then we don't need concatenation anymore, and we need a backtick at the end. Oops. And we're logging the total. Okay. Pretty happy with that. Let's see what happens. 1497. Are you kidding? What's going on? Okay. Sorry, I got some more weird messages again. Okay, so let's submit. There we go. That's the right answer. So we've got 2 of our gold stars already. And that's it. That's it for today. So we've managed to finish with about 20 minutes of free time. I don't know if there'll be any questions. But the code is available obviously in the chat, and I'll put it in the description as well. But that's it. So if we go look at the 2021 calendar, we can see we've got those 2 stars now. It's sort of colored in and reordered any of these images if we needed to. But yeah, that's it. That's JavaScript with Joe Day 1. Join us every Wednesday for another JavaScript with Joe session, and I'll see you soon. Bye bye.